So today's topic is similarity of matrices and diagonalization. So first I will define what is similar matrices. Similar matrices. An n by n matrix A cap is called similar to an n by n matrix A if A cap is equal to P inverse AP where or for some non-singular matrix n by n matrix P. Okay. Then we say that A and B are A cap and A are similar. So what do you mean by non-singular matrix? Non-singular matrix means invertible, right?
Determine
Determinant non-zero. That means invertible matrix. And this transformation, which gives A cap from A, is called a similarity transformation. Okay, this simple transformation is called a similarity transformation, and A cap and A are called similar matrices. So that means we have a matrix A and matrix A cap and A, where A cap is P inverse AP for some P, then we say that A and A cap are similar. Now, the next topic is diagonalization of matrix. This is very important topic. So let me define what is diagonalization. So before that, we are not in linearly independent. Okay, if an n by n matrix A has n linearly independent eigenvectors, then that means if an n by n matrix A has n linearly independent eigenvectors, then D is equal to x inverse Ax. Then D equal to x inverse Ax is diagonal with the eigenvalues of A has the entries on the main diagonal. So what are that means A has n linearly independent eigenvectors, then D equal to x inverse Ax is a diagonal matrix with the eigenvalues of A has the entries on the main diagonal. So what is the entries on this main diagonal on the matrix D are eigenvalues of A, and this X here, X is the matrix with the eigenvectors as column vectors. That means for example if A I am taking a 3 by 3 matrix. A 3 by 3 matrix has three linearly independent eigenvectors. Then by this we will have a matrix D such that x inverse Ax. That means x inverse Ax is equal to D. And what are the diagonal entries? So this is a diagonal matrix with the diagonal entries are eigenvalues of A. And X is, what is this matrix X? Are first column is first eigenvector of A, second column is second eigenvector of A, and third column is third eigenvector of A. Okay. So this process is called diagonalization. So when a matrix is not diagonalizable, when anybody? So when we say that a matrix is not diagonalizable, so here the thing is diagonalizable only if this happens. D is equal to x inverse Ax. What is x? X is the eigenvectors, linearly independent eigenvectors of A. has columns of x. So anybody, when A is not diagonalizable, anybody have any idea? So not a diagonalizable, when you say A is not diagonalizable, if x is not invertible, right? So the matrix A is not diagonalizable if x is not invertible. That means if A has A not has n linearly independent eigenvectors. So when A is not diagonalizable, if A does not have n linearly independent eigenvectors, then A is not diagonalizable.
Sir, excuse me, sir.
Okay, tell me.
Sir, can you use another color there because it's not clear?
Instead of white,
Yes, sir.
okay, I will use black. So x is not invertible. So when A is not diagonalizable, when x is not invertible. So that happens only when A not have has n linearly independent eigenvector. So one thing is sure, if A has all eigenvalues distinct, or A has n distinct eigenvalues, then each eigenvalue we will get an eigenvector which is linearly independent. Therefore, if n has distinct eigenvalues, then A is diagonalizable. If n has repeated eigenvalues, then number of linearly independent eigenvectors depends upon the number of free variables that we discussed last class. Because for example, if you take identity matrix I 3 by 3, then we get 3 free variables, and all eigenvalues of identity matrix is 1, right? Eigenvalues 1, 1, 1. Then we get 3 free variable and we get 3 linearly independent eigenvectors. So here we get 3 linearly independent eigenvectors because there are 3 variables. And in last class we discussed an question number 4. Have you remembered that? In that question number 4, we got eigenvalues as 9, 9, 9. And we get number of free variable 1. So we got only one linearly independent eigenvector. So in this case we cannot take x, right? So if a number of free variables is less than number of repeated eigenvalues, then we may not get a sufficient linearly independent eigenvector. Therefore, that matrix is not diagonalizable. So one thing is sure, if all eigenvalues are distinct, then the matrix is diagonalizable. If eigenvalues repeats, you have to check number of free variables. If number of free variable is equal to number of repeated eigenvalues, then it is diagonalizable. If number of free variable is strictly less than number of repeated eigenvalues, then it is not diagonalizable. So is it clear? Okay, while doing problem we will understand. And one more thing is, if A is diagonalizable, we have D raised to m must be equal to x inverse A raised to mx. So that is very easy to check. So D raised to mx, x inverse A raised to mx. So we already know that D is equal to x inverse Ax, right? Then what is D square? x inverse ax into x inverse ax. Now we know that x inverse ax is equal to identity, right? X into x inverse is identity. Then you will get x inverse a I a x. So this is equal to x inverse a into I a into a square x. So similarly, you will get d raised to m is equal to x inverse a raised to mx. Why this is important? Because if you want to find out a raised to 10,000, suppose you want to find out a raised to 10,000, then it will be very difficult, right? It will take a lot of time if you want to find out a raised to, for example, if you want to find out a raised to 10,000 of an 100 by 100 matrix, then what we want to do, a raised to 10,000 is you have to multiply a in 1,000 times, right? But this is not simple. Even calculator or even computer will take a lot of time. So if A is diagonalizable, then we know that D equal to x inverse A x, and we know that D raised to 10,000 must be equal to x inverse A raised to 10,000 x. Now here we want only to do this. Okay, this implies D raised to 10,000 is very easy to find. If we have lambda 1 0 0 lambda 2 is a matrix, some b, then b raised to 10,000 is very easy. If you have diagonal matrix, then power of diagonal entries, right? 10,000, right? So this is very easy to find. The difficult part is finding this, right? So now it will become very easy, which implies if you multiply x here, which implies x t raised to 10,000 x inverse is equal to a raised to 10,000. So here we need only 3 multiplication to get a raised to 10,000. In usual method we have to do 10,000 multiplication 10,000. So this is one of the application of uh, diagonalization. There are many applications. One of the simple application is we can find matrix product of matrix easily, power of matrix very easily. P is diagonalizable. Okay, have you, is it clear? Hmm? Clear, Ayo? Is it clear? Is it clear? Navya Prasad? Navya is there?
Yes, sir.
Is it clear to you?
Yes, sir. Yes, sir.
Okay. Annie Thomas? Annie is there?
Yes, sir.
Okay, clear അല്ലേ?
Yes, sir.
Okay, now we will do problem. Okay, diagonalize the matrix A is equal to 6 minus 3, 4 minus 1. Okay, so write down this question. 6 minus A equal to 6 minus 3, 4 minus 1. So the first step is, have you completed the question? Okay, now the first step is, what we want to do is we want to write the x inverse ax of the form D. That process is called diagonalization. So we want to find out x. So for that, what is x? X is matrix with the eigenvectors as column. Eigenvectors of A as column. So first we want to find out eigenvalues of A. First find eigenvalues values of A. So find out the eigenvalues of A. So what is characteristic equation? Lambda square minus 5 lambda plus minus 6 minus plus 6 is equal to 0, right? So what are the eigenvalues? Anybody? 1 ആണോ? What is eigenvalues?
-2, -3.
My 2 and
Minus
3 അല്ലേ?
-2 -3 ആണോ? 2 and 3 ആണോ?
2 and 3.
2 and 3.
2 and 3.
Now you find out eigenvector corresponding to find eigenvector corresponding to lambda is equal to 2. First you find out eigenvector corresponding to lambda equal to 2. So what we want to do, a plus a minus 2i into x1 x2 is equal to 0 0. Now you find out eigenvector and tell me anybody got answer? You know, right? How to find out eigenvector? Anybody? Aishwarya? Roll number 1. Aishwarya is കിട്ടിയോ ആൻസർ?
ചെയ്യുവാണ്.
ഓക്കെ. Anybody got answer?
Y is equal to A.
3/4 and 4/3.
3 by 4. Okay,
X
so
is equal to 3 by 4.
x equal to 3 by 4 and
And 4.
Y 1.
y. Y 1 ആണോ?
Yes.
Yes,
Everyone got this answer?
sir. Yes, sir.
Okay. So if you want to take a simple, how to make it very simple?
3 and 4.
You can multiply with the 4. Then you will get, you can take x is equal to 3, 4. Okay. 3 by 4 and 1 is also correct. But we need a simple eigenvector. So any multiple of 1, 3 by 4 and 1 is correct. So I am taking, I am multiplying that with the 4 so that I will get 3 and 4. Have you got any doubt? You can write. Okay, it's clear, right? There is no mistake if you take a 3 by 4 and 1. In order to make it simpler, and just multiply it with 4. Okay, that's all. You can take 3 by 4 1 also. Okay. Now you find out eigenvector corresponding to 4. Sorry, eigenvector corresponding to lambda is equal to 3. Anybody got eigenvector corresponding to lambda equal to 3? It's very simple.
X is equal to 1, Y is equal to 1.
So that means x2 is 1 1. Okay, have you got it? x2 is equal to 1, 1.
Yes, sir.
Yes, correct, right? Is everyone got the same answer? 1, 1 or any multiple of 1, 1 is an eigenvector of lambda is equal to 3, right? So now how to write x? X, therefore, capital X is equal to, our capital X is equal to, you can write eigenvector as a column. So the first column is this
Three,
x1,
four.
3, 4, and second column is 1, 1. Now there is no mistake if you take 1, 1 as first column and 3, 4 as second column. You can interchange columns, there is no problem, but in any manner you can write. Okay, so 3, 4 is first column and 1, 1 is second column. Now what do you have to do? You have to find out x inverse. Tell me what is x inverse. Okay, so for finding x inverse you can use calculator. Today I will upload a video how to uh, find inverse of matrix using calculator and product of matrix using calculator if possible. So you can use the calculators also. So now this is a 2 by 2 matrix. Now you can easily find inverse of this matrix. So there is a shortcut method. Tell me what is inverse. X inverse
-1.
-1
minus
-1
minus
1
3.
minus 1 minus 1.
1. Tell me.
And just 2 by 1.
1 minus 1 minus
1
4 3.
minus 4.
1 minus 1 minus 4.
3 minus 4. Is it correct?
Yes, sir.
Yes, sir.
1 minus 1 minus 4.
Minus 3.
Okay. If you multiply this, you will get 3 minus 5. Okay, correct, right? So therefore, x inverse is equal to 1 minus 1 minus 1, 3. This is invertible, right? So the matrix is diagonalizable. Now you find out x inverse ax. So x inverse is 1 minus 1 minus 4, 3 into A. What is matrix A? Tell me matrix A in the, what is matrix A? 6
6
Minus
minus
3. 4
4
minus
minus 1.
minus 1. And what is X? 3, 1, 4, 1. Right? Now you multiply and tell me what is the answer. So the important thing is you must remember matrix multiplication is not commutative. That means you cannot do this. That means A into B may not be equal to B into A. So while multiplying, you must do multiply this into this. Okay, in this order only. Then the answer you write here and then multiply with this. Okay, so you cannot interchange. Okay, so first multiply this into this into this, then you will get an answer, right? That answer into, you should write this side only, into this. Okay? And tell me what is the answer. Is it 3002 or 2003? Anybody got answer? So here we want to multiply these three matrices. If you have a calculator, you can easily multiply. Okay, what is the answer? Anybody got answer? Is it 3002 or 20303? Anybody got answer?
-200 -3.
-200 -3 ആണോ?
-208 -1.
-208 -1. There is a mistake, right? Okay, 1 minute. That is not. We need. Uh, there is a mistake, right? So tell me.
Characteristic equation sum.
Yes, sir, there.
Sir? -200 -3 ആണോ?
Yes, sir. -200 -3.
-200 -3.
0 minus -3.
And what are the eigen? Is our eigenvalues?
Sir,
Eigen.
inverse correct ആണോ?
Inverse corrected. Inverse is 3 into 4. 3 into inverse 3. Inverse is okay. There may be a mistake. Okay, inverse actually inverse is like this. I will check. Inverse is determinant of a. Oh, okay. There is a mistake, right? Determinant of a is 1 by -1. 1 by determinant of a is there. Okay. 3 3 -4. Okay. Then adjoint of a is 1 3 -4 -1. Right? So there is a mistake here. Sorry. So x inverse is actually -1 1 plus -1. Now you just check. Okay, sorry. There is a mistake in the. So x inverse is actually we have to divide it by determinant, right? Determinant adjoint of a divided by determinant of a. So the x inverse is 1 -1 -4 3. Now if you multiply this, tell me what is the answer. Is it 2003? You have to check it. Okay. So what is if you find x inverse ax, you will get a diagonal matrix whose diagonal entries are eigenvalues of a.